Good morning all students. Hope you are all doing well. So today we will discuss our next topic which is known as Simpson's 3 by 8 rule. So it is also a topic of numerical integration. If you have an integral to integrate from lower limit a to upper limit b with integrand f of x dx. So just like in previous two ways, we use same procedure. We divide the given interval a comma b into n subintervals of width small h, so that x naught is equals to a, x1 is equals to x naught plus h, x2 is equals to x naught plus 2h, up to so on xn is equals to x naught plus nh. So using the similar procedure, this y naught with nothing but value of y for x is equals to x naught. y1 is value of f of x at x equals to x1. y2 is value of f of x for x equals to x2 up to so on. yn is equals to f of xn. In hence, the formula that we call as Simpson's 3 by 8 rule is integration from a to b, or you may say x naught to x naught plus nh f of x dx equals to 3h by 8 y naught plus yn 3 times y1 plus y2 up to so on yn minus 1 plus 2 times y3 plus y6 up to so on yn minus 3. This is known as Simpson's 3 by 8 rule. So this rule is called Simpson's 3 by 8 rule. Now let us do one question based upon this topic. So we have to evaluate integration from 0 to 1 of dx 1 plus x square using Simpson's 3 by 8 rule. Now in this case, the value of h we have to take by ourselves. Let us take this h is equals to 1 by 6. When we will take the value of h equals to 1 by 6, this interval 0 to 1 will get divided into 6 subintervals, equal subintervals. Then x naught is nothing but equal to x1 equal to 0 plus 1 by 6 equals to 1 by 6, and this x2 is equal to 0 plus 2 by 6, which is 2 by 6. x3 is x naught plus 3 times h, so this is 0 plus 3 by 6 equals to 3 by 6. x4 is 0 plus 4 times h, so it is 4 by 6. x5 is x naught plus 5 times h, so this is 0 plus 5 by 6 equals to 5 by 6. And the last value x6 is x naught plus 6 times h, which is 0 plus 6 by 6 equals to 1. So these are the values of x. Now we have to calculate the value of y naught, y1 and so on, all the values. So y naught is f of x naught. So let us put the value in the given function, which is 1 upon 1 plus x square. So your x naught is nothing but 0. So when you will put here, this will be 1 by 1 is equals to 1. Then y1 is nothing but value of f of x at x equals to 1 by 6. So our function is 1 upon 1 plus x square. So at the place of x, we will put 1 by 6 square. So when you will solve and evaluate, this will be 36. So you have to take LCM and then you will take reciprocal. After the calculation, you will get the value of y1 is equals to 0.97297. We will use similar procedure to calculate y2, y3, y4, y5, y6 and all values. So y2 is f of 2 by 6, which will be equal to 0.9. y3 is value of f of x at x equals to x3, which is 3 by 6. So this is equals to 0.8. y4 is f of x4, f of 4 by 6. When you will calculate, this is 0.6923. y5 is f of x5, which is 1 by 1 plus 5 square by 6 square, 0.59164. And y6 is 1 by 1 plus 1 square, which is 0.5. So now we have calculated the values of x naught to x6 and y naught to y6. Now let us just apply and put the values of all these in Simpson's 3 by 8 rule. So what is our Simpson's 3 by 8 rule? that integration from 0 to 1 f of x dx is equals to 3h by 8, which is y0 plus y6 plus 3 times y1 plus y2 plus y4 plus y5 plus 2 times y3. The procedure we are using similar procedure which is given in journal formula. Okay. So now let us put the values of h and all these values in this formula. So 3 by 8 as it is, value of h is 1 by 6. You can cancel out, this will be 1 by 2 and 8 into 2 will be 16. Put the value of y0, y6, all the values, and after calculation we will get in the end that our answer is 0.7857. So this is the procedure to solve the question. Now I'll give you one question as your homework, or you may say assignment. So you have to use Simpson's 3 by 8 rule to evaluate this integration from 0 to 1 x cube dx, considering 5 subintervals. So we have to break the interval 0, 1 into 5 subintervals. So what we will do? We will take h is equals to 1 by 5. So thank you so much for attending this lecture. Thank you.